Hello everyone, this is Sarvesh and the topic is disk scheduling algorithm. So let's start. Introduction. What is disk scheduling? Disk scheduling is done by operating system to schedule IO requests arriving for the disk. Disk scheduling is also known as IO scheduling. In simple words, we can say a process makes the IO request to the operating system to access the disk. Disk scheduling algorithm manages those requests and decides the order of the disk access given to the request is called disk scheduling algorithm. Okay, to understand this more deeply, let's proceed. So to understand this thing, we will understand the architecture of the hard disk. Over there is a diagram. Hard disk is first of all collection of multiple platters, means in one hard disk there will be multiple platters. So what is the first terminology over here is platters. As you can see, the blue circular plates are called platters, means these are platters. Okay, so what is the first terminology over here is platters, and in every platter there will be different tracks, and what will be inside every tracks? Sectors. Means first of all you will have to remember the hierarchy. So the first term is platter. Platters you can understand like they are used to be CD, like it's looking like the shape of CD, right? So CD used to be in circular shape, that you can assume as a platter. You can say that after combining multiple CDs, one hard disk made. Now, if I take out one CD, that is one of the platters, means what will you be on that CD? Surface. There is one upper surface and one lower surface. Means if this is a platter and this is surface, okay, so the upper one is called upper surface and the lower part is called lower surface. So the second terminology is surface. Now, if I talk about one surface, what will be on that surface? On that surface, you will see so many circular lines like this. This is some circular lines, and these are called tracks. These are called tracks. These circular lines are called tracks. And what will be inside that tracks? On these tracks there are sectors. On this track there are sectors like this. If this is a platter and this is upper surface, this is lower surface, this is track circular line, and these small parts are called sectors. Means when the user stored the data, when operating system stored the data on memory, so where does it store? Data is stored in this sector. Now when again the data will have to fetch, then how will we fetch? Obviously we will have to fetch from sector, but how will you reach to that sector? So to reach on sector, first of all, you have to reach on platters. After platter, I will have to reach to that surface. After that surface, the next thing I have to find tracks, means on that surface on which tracks. There are so many tracks. After tracks, finally I will have to reach to the sectors. Means first is platters. On this, over this platter there are surfaces. On this surface there are tracks. On this track there are sectors. Okay, I think now you can understand or view more easily. So the next, then in actuality I will find that data. When I will reach to that sector, I will find my data that I have stored on that sector. From the platter to reach to the journey of sector, who helped me over there is equator arm. These are called equator arm, with the help of which I can reach to that sector. Here what is kept above over platter is read write head. On this arm there are, on every arm there is read write head. In actuality, what are the characteristics of this read write head is that it moves backward and front, means it will move this way forward and backward. So every platter will have its own read write head above it. What is the basic goal of this scheduling algorithm over here is that we want to minimize the service time. That's why we use this scheduling algorithm. So the first uh, terminology is platters. Over this platter there are so many circular plates which are called tracks. On these tracks there are so many sectors, and we the journey from which arm uh, to reach sector is called seek time. Okay. so why this scheduling algorithm is important? This scheduling algorithm is important because of this following 3 points. First, multiple IO requests may arrive by different processes and only one IO request can be served at a time by the dish controller. Thus, other IO requests need to wait in the waiting queue and need to be scheduling. Means this scheduling algorithm are needed because a process can make multiple IO requests and multiple processes run at the same time. The request may be located at different sectors on different tracks. Due to this, the seek time may increase more. This algorithms help in minimizing the seek time by ordering the request made by the processes. So that's why this scheduling algorithm is important. Second, two or more requests may be far from each other, so can result in greater disk arm movement. Third, as you know, the uh, hard drives are the slowest part of the computer system and thus need to accessed in an effective manner. That's why this scheduling algorithm is important. Some important terms that come under this scheduling algorithm are: first, seek time. Seek time is the time taken to locate the disk arm to a specified track where the data is to be read and write. So the disk scheduling algorithm that gives minimum average seek time is better. So in simple words, we can say it is the time taken by disk arm to locate the desired track is called seek time. Means if this is a platter and this is a arm, okay, and my these are tracks, and I have to, with the help of this arm, let's say my data is on track number 3. So when my arm reaches to track number 3 is called seek time. Okay. Second point is rotational latency, or we can say rotational delay. Rotational latency is the time taken by the desired sectors of disk to locate into a position so that it can access the read-write heads. So the disk scheduling algorithm that gives minimum rotational latency is better. In simple words, we can say the time taken by a desired sector of the disk to locate itself to the position where it can access the read-write head. It's called rotational latency or rotational delay. After this, the third important term is transfer time. Transfer time is the time to transfer the data. It depends on the rotational speed of the disk and number of bytes to be transferred. In simple words, it can say that it is the time taken to transfer the data requested by the process is called transfer time. Fourth, disk access time. This access time is the sum of the seek time, rotational latency, and transfer time. Means the three above terms, important terms, if we will sum them, three, of them, then we will find this access time. Next is this response time. Response time is the average of time spent by a request waiting to perform its IO operation. Average response time is the response time of the all requests. Various response time is measure of how individual requests are served with respect to average response time. So the dish scheduling algorithm that give minimum variance response time is better. In this figure you can with the help of this figure you can understand this more easily. Okay, like if you will sum seek time, rotational latency, transfer time, so you will find this access time, and if you will sum all of the four, you will find this response time. uh, so the what is the basic goal of dish scheduling algorithm over here is what we want to minimize the serve time. Okay, so to minimize that, I have we will have a different methods over here. First is FCFS, first come first serve. Okay, second is SSTF, shortest seek time first. Third is scan. Fourth is look, and fifth is CLOOK, and one more is that C scan. But in this video we will learn only look and cloak with examples. Okay, so what is look? In this algorithm, the disk arm moves in a particular direction till the last request is found in that direction and service all them found in the path, and then reverse its direction and serve the request found in the path again up to the last request found. It's called look disk scheduling algorithm. To understand this more easily, let's discuss one example. So here is example. So there are some requests to addresses are given like 82, 170, 43, 140, 24, 16, 190. This. Okay, so firstly we will start from 0 to the highest request is given 1 plus, that means 10 plus we have to write. Okay, we will arrange this in a particular line, and as you can see the read write aim is start at 50. Okay, so we will start from 50, and what looks this scheduling algorithm say you have to go till the last uh, request address given, means here the biggest is 190, so we will go till 190, and in between all the requested, that is 82 and 140, so we will fill this their request also, right? 170, so you have to fill the request of all this, and from after filling the last request you have to come in reverse, like here has given 43, so we will fill the request of 43, then 24, and smallest request 16. So in this way look this scheduling algorithm works. I hope you understand. Means f- first we have to start from 50 as it is given in the question, then we will go from the last request, means 90, and in between all the request we will fill, and we will come backward by filling all the requests, means firstly we will fill 43, then 24, then 16. In this way look algorithm works. Next, so we will find the seek time of look algorithm, means 190 minus 50 plus 190 minus 16, means the last one is 190, this till 50, so we will minus 190 minus 50, and in the same way 190 minus 16, So we will get the seek time. 190 minus 50, that is 140, and 190 minus 16, that is 174. So the sum is 114. So the seek time for a looks this scheduling algorithm is 314. Next one is CLOOK. C means circular loop. This algorithm This algorithm is also the same as the look algorithm. The only difference between look and circular look is that it moves in a particular direction till the last request is found and serve the request in its path. Then it result in the opposite direction till the last request is found in the direction and does not serve the request while returning. Then again reverse the direction and serves the request found in the path. It also moves circularly. Okay. So to discuss this more easily, let us take an example. So there is an example as we have taken in look. So there are also requested addresses are given like 82, 170, 43, 140, 24, 16, 190. And in the question that is given, we have to start from 50. Okay. So what it say? Firstly, it it goes same like loop, means starts from 50 and it go till 90, and in between all the request type 82 and 140 and 170 request will be filled until 190 it will fill. But in look what happens, it when it comes return back, it fill the requests of others. But in this C loop, it will go from here, it will directly reach to the lowest request, means 16, and from 16 it will again back to fill the request of 24 and then 43. So it looks like a circular path. That's why it is called as circular loop. So I hope you understand what is this scheduling algorithm and why it is important, some important terms, and two types of this scheduling algorithm, means look this scheduling algorithm, and C look means circular look this scheduling algorithm. Thank you.